Algorithms to instructions, instructions to bits. It is not that we should detest ourselves for failing to understand the solution to an algorithm involving a question that we ourselves have only just come to comprehend. When we find that it is past midnight, when we find that we must subdivide a single object repeatedly with a branching factor of 2. Take, for example, our first whole object. We know that upon branching into 2, we receive the following. Now let us introduce the concept of conditional branching. Not in the sense of programming, but rather a conditioned function which decides whether or not we split our current object, our current piece, into another 2 pieces, which are probably going to be halves. Okay. We call this function Q. Boolean. True or false, good and evil, up and down, light and dark, branch or don't branch. I realise that terminology is easily confused with the programming instructions, so I'll try and avoid that. We can number these. We're going to number these pieces. That's going to be Q1. Now this is also going to be Q1. And this can then be Q2. And we're going to have to introduce the concept of levels. Which is level 0. It's level 1. It's level 1. It's a 0 because 2 to the power of 0 is 1 at one hole. You see the one hole there? You see it. You might see now that we could call this Q sub n for the number it is, and then n for the level. So n clearly ranges from 1 through to 2 to the power of n. And you can see this continuing here. Q1, 2, Q2, 2, Q3, 2, and so on. What's interesting is that if Q is false in our algorithm, if this ends up being false, that means that one never actually reaches Q sub 3.2 or Q sub 4.2. So if that, upon reaching an F, because we're going to assume everything exists is true, and doing some big data structure that accounts for all of that would frankly be it's beyond me right now. Take a little space. For my application, it's going to be clear that at points between all of these, they join each other. I'm going to name these P 0, 0, and P 1, 0. P 0, 1. P 1, 1. P 2, 1. Again, the first number increasing up to 2 to the power of the second number. P 0, 2. P 1, 2. P 2, 2. P 3, 2. P 4, 2. And you'll notice again upon failure the points also are useless. So Q is going to be essentially a function of P, the members of P that or subscripts to be adjacent to that number on that level for Q. Conditional, showing whether to subdivide further or not. We note that Q, upon subdivision, spawns a P. It's responsible for a point created in the division. And then that stays the same, just as these stay the same, it's equal to the same thing. Amazing. We want to traverse this, we want to subdivide conditionally. Because we rely on Q, we can't be these, children left node, child first, traversal, depth first stuff. It has to be essentially how I've been thinking on it so far today, mostly. This stuff is that one goes left node. Okay, so it's not about depth first versus breadth first in this algorithm. It's rather in order traversal. And this is the one in which the head appears first, the parent and then the left child. Parent, Q10, Q11, Q12, Q22, Q21, which is in toy here, doesn't action, so we then go back up. So I thought about what's the way in which you could move from each of these, only holding the information necessary to evaluate Q, which relies on its two neighbours. So at any given point in this algorithm, you're going to want to have, what I'm calling L and what I'm calling R, left and right points. And what you're also going to want is a stack of points that allow you to go back up the tree. How I'm envisioning this happening is to have a state machine that I'm going to work out revisit the notes. We have these two, that's L and that's P, and we go, having subdivided, this being true, move down here. Well, that stays the same, but we're going to need to set R to be this. So, in my mind, this gets pushed onto a stack there, and this gets allocated. P11 goes into R, goes to the R slot. So if I'm left and right, P01 and P11. P10 is left so that when we go to the action of up, which is going to be one function step, going back up the tree, we're going to have two others. Down, left, which is where we go there. And then we're going to have, once we've reached a false dead end when we go across to go there, and that's going to be across right.